Hello everyone. So today I'm here once again with another data set, which is where we need to predict the admission in based on certain features, which is GRE score, TOEFL score, university ranking, SOP, LOR, CGPA, research, and then we need to that's our target column, which is chance of admission. I mean, where we need to predict the probability of getting the admission into UCLA. So this is the data set that we are going to utilize, and I have already written the code. So we need to predict admission. So these are the basic stuff that we need to follow. First, I have imported the required libraries and then the data set. So data set here, the one that I have shared you here in Excel is the one we are going to read it here. So this is the shape of the data, which is a very small data set where we are having 500 rows and 9 columns, and head is just to get the top 5 rows of the data set, where we can see that serial number, GRE score, and all the columns that we have seen into the that Excel. Tail is just to showcase the bottom 5 rows, and then we have columns just to check the total number of columns and their the names. And then information, these are some basic thing that we basically apply on all the data set, where we see the total columns and their count and the data type, everything at one place. And then I have used describe to get the basic statistic summary, and you see that here it take by default all the numeric columns. So we have almost all the columns are numeric, where we can see that based on the describe function, but we can check basically how our data is distributed. I mean, the mean value of that particular column, the deviation, the standard deviation, the mean value, where we can see that for TOEFL score minimum value is 92 and the maximum is 120. And for GRE, that is 290, and this is the max value is 340. And same we can check for for university rating, that is 1 and goes till 5, and some other columns as well, right? And the lower quartile, the median, and the upper quartile, that's what we can see. And sometimes it happens that if you see the upper quartile and the max value, if we find there is a huge difference, so which help us to to understand the variability into the data. And let's say, for example, your upper quartile is here, let's say 375 something, and your max somehow goes 5,000. So we can see that there is a huge difference in between the upper quartile and the maximum value. So we can consider that we have some outliers in the data set. Here we don't have outliers. That's what we can see, that mostly all the upper quartile and the maximum value sync in, and there is no huge difference basically, right? So transpose we can use it here. So it will basically, what it will do, whatever we have as an index, it will go as a column, and the column will become our index. So this is just to showcase it. This is just for the visual purpose. And the D types, although we have already checked the D types based on the information, but still we can check the data types for each and every columns here. So we can see that all the columns either integer or the float. There is no object column in our data. Now we are going to check that whether we have missing values in the data set or not. So it says that no missing values, that which is as null dot any false. So apart from this, what we can do, we can check simply with sum as well. So df dot is null and then dot sum. So it will give you the sum of all the missing records correspondence to each and every column. So we don't have missing records. We are lucky enough. No missing values, and all the columns are already either integer or float. Now we are going to rename some of the columns because although it is not required, but it's up to you that in case you want to rename, you could do it. So here I'm using a rename function, and in that renames within a column method, I have passed a dictionary, and that dictionary I have used key as existing column name and value as a new column that we want to rename. So GRE score, we are going to convert it as GRE, and same for TOEFL, and then LOR, LOR you have put it as same, but still in case you want to make changes, then you could do it. And chance of admit, you are going to rename it as probability. So once we run it, and we have basically assigned it here only. Otherwise, what we can do, let me write that code as well. We can do it with the use of, in place as well. Let me write it here. So then we don't need to, assign it to a different object. Here I'm just commenting it. So once you are going to try it, you can check it with that way too. So with the use of in place, we can make changes to the master data here only. We don't need to assign it to the same data frame. So this is just to, make our code more optimized. So that's why we use in place for that matter. For example, in case you are storing after renaming to a different data frame, then you can do it like this. But here we see that we are storing to the same data frame. So better to use in place with true. So this is just to add here. Now we can see that columns has been changed. Whatever the change column name we have given, they are shown here. So GRE score becomes GRE and TOEFL becomes TOEFL, and chance of admit is the probability now. Now we are going to do a bit data visualization where we are going to visualize the feature GRE. So that we can see what is the distribution of the score, GRE score here in the data set. So let me run it, and we see that the data set almost normally distributed data is here. So the minimum is like here, the count, the occurrences basically. This is the score and the occurrences. So the majority of the occurrences, which is more than 80, is for this range. You could consider is 325 somehow. And then 315 also, 1215 is the range that we can consider. So majority of the score lies into this. And although the minimum score 290 is also there, very less count available for this, and for 340 is also very less count available. But the majority of the, the data values lies into this range. That's what we can see. And the same we can do for TOEFL. Let me explain the code as well. So we have put it the histogram here, and histogram we have selected the data frame and the column. R width is the option to, give the width. In case you don't mention it, it will take the by default width. And title, you just give the whatever the title you want to have for a particular plot, and the label of X, what your X represent, and the label of Y means what your Y axis represent, and you simply put show. So once we run it, we see that here also for the TOEFL score, we can see that this is the highest histogram bar, you could say. And here for 105 to 110, here we have the maximum occurrences. The count, majority of the count lies into this range. Although we have more than 50 almost count for this range as well, and the 70, you could say around 70 is for this range, and the very less count available for this score. Correct? So we have very few records where we have this score available. So this is what we observe from here. Now, we are going to visualize the feature university rating. Let me copy this here. Yes. So what we can see, that the rating distribution of the universities here. So the rating is like 1 and starts from 1 and goes till 5. So the majority of the rating lies between this. That's what we can see. Overall, almost 160 counts are there for 3 to 3.5 range, right? Now, let's visualize the distribution of SOP. So let me change this as well. I just simply copy pasted that. And here, that is the distribution. So here also we can see that we have the maximum count for this rating, like 3 point, which starts from 3 and goes till 4, or let's 4.2, something like that. So we have this distribution of the rating for SOP rating. That's our understanding is. And then we can visualize LOR as well. That is also one of the column. So we can see that This is the distribution of it. So why we visualize it? Just to check that how our data is distributed based on the different columns, to get the idea what is happening there, right? And the other feature is CGPA. So CGPA as well we can see. So let me run it. And that is the distribution of CGPA. So that is also kind of a, normally distributed values are find here. So the occurrences we have based on CGPA is like majority of comes into this range. More than, you could say, 90 counts are there for this CGPA, which is 8.5. And for this, as the CGPA increase, we have lesser count. As it decrease, we also have lesser count. So that's what we can see from here. And then we can, the research feature is also there. So let's visualize it as well. So for the research, you can see either we have, 0, or we have 1. So that is the distribution of it. So, the distribution of the data is almost 225 records belongs to the 0th category, and more than 250, around 270 or 80 you could consider, belongs to the 1 category. So that's the distribution of this column. Now we are going to do a bit data cleaning. After visualizing the data a bit, now we are going to remove this serial number, which is just a normal sequence, which we doesn't required as a feature. So we can, which doesn't make any sense. Like whatever the serial we have, we cannot put it as a feature to predict the model or to build a machine learning model. So I simply dropped it. Here I have used in place equals to 2 and axis equals to column. So you can use axis equals to 1 as well. 0, axis equals to 0 represent rows and 1 represent column. So you can use 0 and 1 as well. So here it goes. After dropping the serial number, that is our data. Now we have some, 0 to some of the columns we have noticed while we did the description. So we are going to, we are going to convert that with nan values. So wherever we find 0, we are going to replace it with nan. Basically, for Python, how we represent 0, that is represented by nan, not a number, what we call it. So what we did, we have selected all the columns, the required columns, and then we did replace all the zeros to np.nan. This is what we did. There are multiple ways to do it, and this is one of the way. So we have already made the copy of it, put it here. So that's our original data is df, and everything we are going to do into a df underscore copy. And then after replacing all the zeros to nan, we again try to check whether it has added any missing to our data or not. So we have validated it and our data is good to go. There is no null found in place of all the columns. Now, that's a very basic small data set. So the beginners can start with it. And our data is ready. Now let's come to the model building phase. So the target variable was the probability. Apart from probability, we want everything to be into as an input feature. So we have dropped probability from the data and put it everything into X. And the probability needed as a target variable, which is our Y. So we have, divided our data into X and Y. Here it is. So everything except probability that is there in X, and only probability column is there in Y. Now we have imported the required algorithms. So we have imported GridSearchCV just to to select the better algorithm or the outcome from the model, and all the regression algorithms we have imported: the linear regression, lasso, support vector regression, decision tree regression, random forest regression, and k-neighbor regression. So we have imported all. Now what we are going to do, we are going to create a function to calculate what is the best model for this use case. So I have simply created find best model function where I am going to pass my input and target features, which is X and Y, and then into the model I have passed a dictionary, and into that dictionary I have passed all the model the name of the algorithm, and I have created the object using that algorithm, and the parameter I have passed whatever we required for it. So that first is for the linear regression, second is for the lasso, and we have created this object, and the alpha and the selection based on random or cyclic we have passed as a parameter. Support vector regression we have created, where we required gamma as a auto or a scale, and the decision tree where we have into the criterion we have mean square error and Fred's mean square error, and to the splitter that is best and random. And now let's go to the random forest. I have put it criterion MSC and the number of estimators and the k nearest neighbor regression as well, with some the neighbors with the value of n. I have passed it here, and then what I did, I created a empty score list, and I have loop out all the model. I have once I apply a for loop on model dot items, it return two outcomes. One is the key, which is model name, and the other is the value, which is model parameter. So I have put it model name here and the parameters are here. Then I have used GridSearchCV where I can pass the model and the parameters, and then cross validation I did for 5, and then I used uh, a fit method to pass x and y, and then a score I appended. Score into that list I have appended all the model, their best parameter, selected best parameter, and the score as a dictionary. So there will be a dictionary inside a list, and then created a data frame based on the score and the parameters that I have passed from the dictionary. I'm going to give it a name model, best parameter, and score. So once I run it and the find best model with xy parameters, I can see. So this will take a bit time. Yes. So we see that we have this model linear regression, and that is the best parameter it has selected, and that is the score. And then we have lasso, which is 0.21. It's absolutely not working here. Then this SVR, we have this score, and for decision tree, that is this 60, and for random forest, that is 77, and k nearest neighbor is the 72. So we got linear regression as the highest performing algorithm here. So what we can do, we can do some cross validation based on this particular algorithm, where I find out that this is the algorithm which suits best to this particular problem. So we have imported the model selection sklearn import model selection and the cross validation score. Into the cross validation score, we are going to pass linear regression and then the cross validation value with these input and target features, and then we have calculated the accuracy based on that. So once we run it, we find that accuracy is 80%. So that is 81% basically, not 80. So this is the accuracy we got from here. Now a model is prepared and we check the accuracy as well. Now what we can do, we again use the train test split method. I've used the train test split method so that further we can validate that too. So that is the distribution of the data, 80-20 ratio we have put it, and we have created our variables, and then we again pass that and check the score. So this time the score is bit better, which is 82%. So later what we can do, we can check with the whatever the test data that we have prepared, we can validate it and we can check that one by one. So what is the difference which is coming now? Let's say that was the total accuracy of the model, and now for example we want to give some the, let's say, input feature whatever we pass to the model, and check what is the probability of getting admission into UCLA. So we have passed, hope you remember that the input for x was this. Let me showcase you the head here with two values. So that was our x. So where the first parameter that we passed, the first feature was GRE. So we are going to put the score of GRE and then the TOEFL and then university rating, which is 4, and the SOP, which is 4.5, and LOR as well 4.5, and then 9.65 for CGPA. And then this is the research for, research is 0, where we had two outcomes, 0 and 1, and then we calculated the probability of it. So there is a 92% probability to get the admission into UCLA, where we have GRE score is 337, TOEFL is 118, university rating is 4, and SOP and LOR rating is 4.5 with 9.65 CGPA, and the research value is 0. So this is what we can see here. Let's take another combination of these input features, where we have put it like 320, the GRE score, and that is the TOEFL one, and the university, and the SOP LOR, and then CGPA and research. So once we run it, we see that, because you see that here comparatively to the first prediction, we have taken the less GRE score, we have taken the less TOEFL score, and university rating is also less. So you can see that the chance of getting admission into UCLA is 73, which is lesser than the previous input features that we have passed. So this is how we have prepared a very basic model. That was the regression problem. So this is how we have created. What you can do, you can try to reduce some more errors and make changes to the data, and try to find out what we could do to make it more better. So this is just one approach, and the very simplest way I try to explain it. In case of any question and query, feel free to connect. Thank you. Thanks everyone. Bye bye. See you in next class.